We will study transportation model today. What is transportation model? First of all, let's understand what is transportation problem. So let's see what it is. Let's say there's a company ABC Incorporations. This company has one, two, three. These are three manufacturing units. Let's say it produces certain items. Whatever be the items, we are not interested in what item it is producing. Let's say it produces certain item. It has three factories, one, two, three. These are the factories that produce these items. So there will be capacity of the factories. So this is supply side, that is these will supply items. Let's say the capacity of this factory, that is first factory, is 1000, second factory is 1200, and third is 1500. That is, first factory can produce 1000 items, let's say annually. Second factory can produce 1200 items annually, and third factory produces 1500 items. This is clear. Now there are four consumption units: 1, 2, 3, 4. Let's say 1, 2, 3, 4. What are consumption units? For example, if these are toys, these can be shops where these items have to be shipped. From there they can be sold. So these are the points where we have consumption. So they can be dealers, they can be shop owners, they can be shops, they can be this type of consumption units. Okay, so these are demanding units, that is units of demand. Units of demand, they were units of supply, these are units of demand. They demand. Obviously every unit of demand will have certain capacity. Let's say this is 1000, 2200, 3700. So let's say this first unit of demand can sell or can consume 500 items annually. These are, let's say these are the productions on annual basis. So these are the consumption on annual basis. Let's say this consumes 2000 items annually. So 2500, then we are left with 1200. So let's say this consumes 700. So finally this will consume 500. Let's see. Yeah, it's okay. Okay. Now we can transport these items from this factory to this factory. We can transport this factory to this factory, and this to this. Similarly, we can transport the items to these consuming units from these supply units. Okay, so this is the type of network that can be understood. Now transporting items, certain cost is always associated with transportation. Let's say you are at Delhi and you have to transport certain item to Mumbai. Obviously that would cost would be associated. A car has to be sent to Mumbai, it will take 20,000, 30,000 for a truck to load and unload. So that is that how we say the cost of transportation is, let's say 500. We are talking in rupees. So 500, and from here to here is maybe 600. Then third one maybe 700. Fourth one maybe 800. And what is the volume of the items transported? Let's say this is 1000. So only 1000 can be supplied. So let's say in simple terms 200, 200, 300. Now what is left? 700, 300. So this is the way we show that out of these 100 items that is produced at the first producing unit, 500 is the cost of transportation of one item from here to here, and we are transporting 200 items from one to one, that is the first production unit to the first consuming unit, and this is the way. Obviously finally we have produced 3700 items per annum, and we have consumed 3700 items per annum. Transportation cost is involved, that is if you try to find out, this will be 500 into 200 plus 600 into 200 plus 700 into 300 and 800 into 300. So if you add them all, that will be the cost associated with transportation of these 1000 items to these four consuming units. Similarly we can calculate for 2 and 3. So this is the issue. Now when you see this, you can understand that when transportation costs are different, there can be a way in which the total cost of transportation will be minimum. So there will be several constraints. So how to find that point or that particular values. Maybe 520, 500 is the cost, then let's say we finally get that 180 items to be transported from here, 210 items from here, and finally the transportation cost is minimum. Obviously we'll what we'll wish that our transportation cost is minimum. So transportation model, what we do, we create a model, and transportation model, actually the objective of this model is to minimize the cost of transportation. So I think you have got this. Let me explain this in, or let me give you the block model of this particular transportation model, how we represent it as block model. See, we say that the supply units, let's say it is 1, 2, and so on up to m, and demand units, it is 1, 2 up to n. Okay, and you know supply is like this. Okay, here also. Then what we say, we let's say we denote it like A1, A2 up to AM. These are the supply units, and let's say this is A, then this is B, B1, B2 up to Bn. Okay, and we write like this: C11, X11. What is 11? That is 1 to 1. C is the cost. That is cost of transporting from first supply unit to first demand unit. So this is C11. Here will be C12, and X is the volume of items supplied. So here will be X12. That is what is the cost and what is the volume of transportation. So we can say, how we write? We say Cij, what it is? Cost of transportation per unit. And you know what is Ij? I will be from 1 to m and j will be from 1 to n. So cost of transportation per unit. Xij will be volume of items transported from one supply unit to one demand unit. So it will be 1 to n, j will be 1 to n. Clear? So this is the model. This is how we represent it. So what we do in transportation model, what we do, I think you must have understood this. So what we do, we create transportation table, simply called. So how do we create that tableau? See, what we do, we let's say we have 3 production units and we have 4 demand units. Okay, so what we'll do, we will, let's say this is 1, 2, 3, that is the production units. So 3 for this and 4 for, and we have supply units here, 4 supply units. Let's say these are supply units 1, 2, 3, 4. So this is 1, this is 2, this is 3. So this is a table. These are production units or supply units, and these are demand units. Okay, so first unit will supply to all the 4 demand units, the second production unit will also supply to all the 4 units, and third will also supply to these. This is clear. So what we do, we write the cost of transportation here. I told you from 1 to 1, C11, we write the cost of transportation here. So we'll write here C12, C13, C14. If it was rupees 500, we'll write 500, 600, 700, 800. Similarly, here will be C21, that is cost of transportation per unit, and this is in per unit. So per unit from 2 to 1. Then C22, C32, C32, it is 23, 2, 4. Then is C31, C32, C33, C34. Okay, so this way we write the cost of transportation. Then what we do, we write the volume of transportation here, X11. That is, let's say we transport 500 items from the first supply unit to second supply unit. So this way X12, X13, X14, X21, X22, X23, X24, X31, X32, X33, x3 4. So now this is, in these cells we write like this. So this corner, when you see, you know this is the cost per unit of transportation, and this is the volume of transportation. So if you want to know what is the transportation cost of transporting items from 1 to 1, so we know we transported x11 items and the per unit cost was c11. So x11 plus c11, this is what will give to the transportation agency. It may be truck agency or train agency, whatever it be, will be giving x11 into c11. Similarly, everyone. Now, these are the number of units, and you know there's a limit to what this unit can produce. So here what we will write this summation xij, this one. See this one, not ij, summation x1j, where j will be from 0, sorry, not 0, j will be 1, 2, 3, 4. That is x11, x12, x3, x14. So if you add them all, what you will get? You will get the number of units that this supply unit can produce. Okay. Similarly, here what you will write? x2j summation, and here will be x3j. So now this plus this plus this plus this is written here. So when you see this side, you know these are demand units. These are demand units and these are supply units. But what is this? This is supply. This is supply. Okay. So if you add them all, there we had 3700. So if you have, if you will add, this will 3700 for that particular example. And here, this unit has its capacity to consume. Demand units also have their certain capacities. That will be this plus this plus this. That is, this will be xi1, where I is 1, 2 and 3. Okay. So x11, x21, x31. So if you add them all, at the max, it can be this only, xi1, this will be xi2 and so on. That is, here what you will get? You will get demand. When you look, what you do? You add all these. So when you look at this figure, you know this unit can take this only. So this is the way we create this table, this transportation table. Or so if you have the figures, you can create this table, and if you have the table, you can then start with it. Next issue will be how to reduce the or minimize the total transportation cost. Okay. Now let's understand this, because we have seen linear programming problems. We have seen how to formulate linear programming equations. We have used simplex method and all. This table, what we try to achieve from transportation model? See, our total transportation cost, let's say it is Z. What it will be? If we have 1 and 2, I'm only taking off 2 into 2 units. Okay, that is 1. Let me draw it. We have 2 supply units, 1 and 2 demand units. Let's say this is 10, this is 20. So this is the 30 demand of this. This is 30 and 20. So this is 50. This will be 40. That is, this unit produces 40 units and this unit also produces 40 units. So supply side, total supply is 80 units, and demand side, this is 30 plus 50, 80. Okay. So, and the transportation cost is C11, let's say C11, C22. So what will be the total transportation cost? It will be X11 into C11, then X12 into C12 plus X21 into C21 and plus X22 into C22. So whatever these figures be, if you multiply them and add them all, this is the total transportation cost. And to minimize this is your goal. Now this is linear programming. You can see this is LP equations based on linear programming method. And there are constraints. We have constraints. For example, in this example, the constraint can be x11 plus x12. This can at the most be 40. This is production from unit 1. Similarly, x21 plus x22, we had given 40 to this also. So this is also second constraint. Similarly, we can have constraint from the demand side, x11 plus x21, the first row. This was, we had seen 30 and x11, x22. Now here what we get? x12. So x12 plus x22, this was 50. And you know, xij and your cij, these all are greater than equal to 0. So now you see, this is linear programming problem, LPP. This is LPP. You can solve it by simplex method, but transportation model allows you to solve it in a more efficient and easy manner. This you know how to solve. But what we'll do, we'll, instead of using the LPP model, using simplex model, what we'll do, we'll use the transportation table and we'll see how to solve this equation. That is how to minimize z. This is our objective. So I think now you will be able to correlate between simplex method and transportation model. So let's see. So you must have read the question. It is a big question. The words, there are so many words to explain. We'll see how to reduce it into a simple tableau. So the question says that there are 3 production units A, B, C and 2 consumption units X and Y. The yearly production capacities of the 3 units are 1000, 1500 and 1200 items. The demands at the 2 consumption units are 2300 and 1400 items. The distance between the plants and consumption units, it is given like this. Let's say these are the production units A, B, C and these are X, Y. So it says the distance between these two are like this: 1000, 2690, 1250, 1350, 1275, 850. These are in kilometers. So this is the distance from A to X. This is production unit. This is, let's say this is a car production unit. So the car has to be transported 1000 kilometers to reach X. So these are in kilometers, and it is given that the transportation cost per unit is 8 paise per kilometers. Okay. So what we do, we multiply it with kilometers, we will get cost of transporting 1 unit. This is cost of transporting 1 unit per kilometer. So when you multiply this, that is 8 paise into 1000, what you will get? You will get 80. That is transporting this one item from A to X is rupees 80. Now we will change the units, rupees 80. Clear? So what we will do, we will multiply all so that we get, the values are 80, 215, 100, 108, 102 and 68. So transporting an item from B to Y is rupees 108 per unit. So this is what? This is C. So we know what is CAX, CAY, CBX, CBY, CCX, CCY. This is known. So we, how to make that tableau? See. A, B, C production units, and we have 2 X and Y. X and Y as the demand units. Clear? So what we'll do, we'll write the cost of transportation of 1 unit from here to here at this point. I told you C11, C12, so this is like this. It is 100, 108, this is 102 and this is 68. Okay. Then we know that in the question only it is given that the 3 production units A, B, C, the yearly production capacities of these 3 units are 1000, 1500 and 1200 items. So A can produce at the most 1000 items, B can produce 1500 items and C can produce 1200 items. And the demand capacities of these two are 2300 and 1400. So this you know, adding them all. We have to find, the question will be, for the time being, the question is to make this table only. But the ultimate question will be what volume to be supplied from each unit to each demand unit. So let's say this is X11, this is X12, this is X21, this is X22, this is X31, this is X32. So this is where we write the supply, this is where we write the demand. What will be the total transportation cost? It will be X11 into 80. So 80 X11 plus 215 X12 plus 100 X21 plus 108 X22 plus 102 x31 plus 68 x32. So our problem is to minimize this z. The constants, you know, x11 plus x12 is 1000, x21 plus x22 is 1500, x31 plus x32 is 1200, and x11 plus x21 plus x31 is 2300, x12 plus x22 plus x32 is 1400. So these are the constants. So this is how we make the table. Now the beauty of this table is that if you are given with nothing, instead of those so many words, question in so many words, if only this table is given, just by looking at this, you know that these are the production units. This unit produces 1000 items, this unit produces 1500, this unit produces 1200. These are demand units. This has the capacity to demand 2300, this has the capacity to demand 1400. This is the cost of transporting this volume of item, per unit, on per unit basis from A to X. So this table actually gives all the data that you want. This is the beauty of this table. Okay. This type of model is called balanced. Why? This type of model called balanced. Why? Because supply is equal to demand. See, we are producing 3700 items and our consumption is 3700. That is, supply is equal to demand. So this is a balanced model. Clear? But this can be unbalanced also. Let's say this produces only 1300 items. Then if it produces only 1300 items, so this will be 3500, but the demand is 3700. So there will be a gap of supply of 200 items. So in that case, what we do, we create a dummy supply unit. Let's say the name is D for dummy. This is a dummy supply unit which supplies 200 items. Okay, so let's say this is x41, x42. So x41 plus x42 will be 200. What will be the cost of transportation of item from this dummy unit to this? 0, because this unit actually does not exist. So this and this is the cost is 0. But now this was 2300 and this is 1400. So 3700 and this is 3700. So what we did, we created a dummy supply unit when the supply was less than demand. For what? For balancing the model. How we'll use it and how we'll come to conclusion, how we'll minimize that is another issue. We'll look at it later on. For the timing, you should understand, if the supply is less than the demand, we create a dummy supply unit. Another situation can be, let's say this is producing 1500, that is, total production is this much, 3700, but our demand reduces. That is, instead of 2300, let's say it demands 2100 units only. That is, this is the case when supply is greater than demand. There will be 200 items of no use, they will be surplus. So what we do then, in that case, we create, since the supply is more, we create dummy supply unit. Let's say this is the dummy supply unit. Okay, and the volume supplied to it will be x13, x23, x33. So this is 2100, 1400. We'll take this plus this plus this equal to 200. Cost will be 0 because these units actually don't exist. So we don't have any of this. But our model is balanced now. So this is how we convert from inequality to equations. We balance the model. So this session I end at this point. I have explained to you what is a transportation model, why it is required, how that table is created. This I have explained to you, what is balanced, what is unbalanced, and how to balance. This I have told you. In the next session, we'll start with certain exercises, and then we'll understand how to minimize Z. That is, how to reduce the transportation cost. We'll be looking, actually, as we did in simplex method, here also we'll start with basic variables, basic feasible solution, and we'll be using 3 different types of methods. First method is called northwest corner method. Second is called least cost method, and third is called Vogel approximation method. So these things we'll see in our next session. For the time, for now, you should understand what I have told you in this session. Okay.